1999. I am pleased
Hi!
Good day, Ma'am Giselle. We are the Team Robotics.
Entitled Simple Radio Control Robot, a cardboard-based model.
By the way, I am Joshua Daniel Zapanta, and for this video, we are going to present our product and how we made our simple cardboard robot, together with my productive group mates.
I'm Cyrene.
I'm Ivan.
I'm Chinchin. I'm Jamaica. I'm Missy. I'm Micah. I'm Magella. And I am Rhea. And this is Rhea May E. Baksal. Please keep on watching.
In this section, we're going to discuss our laboratory objective. Our purpose in this experiment is to design, analyze, and test an intelligent robot that behaves and walks exactly like the simple and understandable model. Simple radio-controlled robot, cardboard-based model. This would contrast with how engineers usually develop controls for robots. First, they build the hardware and identify how the hardware works as a system. Then they write controllers to make the system do what they want, says Hurst. We want to build a robot that walks based on a very simple stripped-down model, one that lets us easily develop controls for it using RC car from cardboard.
The laboratory materials. First, we have cardboard sheet, then RC car, rubber wheels, cycle spokes, RC car motherboard, battery, DC gear motor 100 RPM, some glue sticks used with a hot glue gun, and lastly, cutter.
Let us now turn our attention to laboratory procedure. Laboratory procedure is to describe the steps or guidelines that will be used to carry out the study of making a simple model walking robot controlled via a cardboard-made Arduino powered, and instruct how to safely carry out an action in a laboratory environment. This section will discuss the procedures and measurements that we propose to use in our project.
1. Prepare all the materials needed. Some glue sticks used with the hot glue gun, cutter, cardboard sheet, 2 different size boxes, one for the head and one for the body, RC car, rubber wheels, cycle spokes, RC car motherboard, battery, DC gear motor 100 RPM.
Step 2. Dimensions. As per diagram, take the dimensions. We just need a 20 cm by 11 cm cardboard. Draw the lines as per the pattern. 3 pieces 20 cm by 15 cm. 2 pieces by 14 cm by 15 cm. 1 piece 11 cm by 14 cm. 2 pieces 100 RPM gear motor. 4 pieces mini wheel. Cycle spokes. Step 3. Make the platform. Step 4. Prepare the box for the head.
Step 5. Attaching the arms. Figure out where the arms are supposed to go on the robot body. Use the side of the boxes that are flat, not the sides that have the flaps overlapping. Once you know the placement, measure from the top and edges and mark the spot on each side of the box so that the arms are even. Cut a hole slightly smaller than your arm in the box. Cut slits outward from the hole. Stick the arm in the hole created and position the arm.
Step 8. After finishing touches, attach the other robot materials. The intermediate device between the DC gear motor 100 RPM and battery provides current to ensure all components work appropriately. Motors for rotation of wheels and allow the robot to move around. Vehicle kit or robotic platform. The body of the robot for mounting of parts. Step 9. Testing the robot. After that, Port it to the microcontroller to check for the working of the robot. Generally, you will get some error in the beginning. Just note down the errors and then modify the program code or calibrate the sensors to make the robot work efficiently. This process should be repeated till you arrive at the proper functioning of robot. Step 10. Make it walk.
Next, let's move on to the results and analysis, followed by the conclusion and recommendation. For the results and analysis, this chapter presents the summary of the work undertaken, the conclusions drawn, and the recommendations made as an outgrowth of this study. The primary objective of this research was to make a simple radio-controlled cardboard robot that moves exactly like the simple and understandable model. For day 1, we started to visualize the project together with the materials, the procedures, and especially the dimensions of each part of the cardboard-based robot for us to arrive at the correct estimation of its measurements with consideration for the RC car's capacity to carry its weight. For day 2, we continue in making what we started in day 1. Then we proceeded with figuring out the arms, attaching the arms where the arms are supposed to go on the robot's body. Then after that, we moved the neck by attaching the neck to the head, deciding where the neck or the solo cup is going to go on the head. Then head to body. And for our last day, which is day 3, we finalized our output in day 2, testing a robot to see if it will function properly. As a result, the total data indicates that the experiment's findings support the achievement of the outcome. The robot operates correctly.
Conclusion. Based on the findings of the experiment, the following conclusions were drawn. Today, we find most robots working for people in industries, factories, warehouses, and laboratories. Robots are useful in many ways. For instance, it boosts economy because business needs to be efficient to keep up with the industry competition. Having robots helps business owners to be competitive because robots can do jobs better and faster than humans can. That is, robots can build and assemble a car. Yet, robots cannot perform every job. Today, robots' roles include assisting research and industry. Finally, as the technology improves, there will be new ways to use robots which will bring new hopes and new potentials.
Recommendation. In making robot like what we did, you can actually use Arduino Uno or like for much effective and amazing output. On the other hand, in our case, that we choose to make use of information wherein we don't use the aforementioned material because it's quite hard for it to involve coding and programming, which will take so much time to accomplish for us.